Now that we've learnt to add and subtract limits of accuracy, we're going to look at multiplying and dividing them. Do make sure that you know how to add and subtract limits of accuracy before you start this video. Have a look at this really nice question here. We have a rectangle with sides 5 centimetres and 2 centimetres, both of them being rounded to the nearest centimetre. And we need to find the limit of accuracy for the area of this rectangle. Now, the area is just each side multiplied together, so we're looking at multiplying these limits of accuracy. Let's find the bounds of each side. We know the longest side, which we'll call L, will have a lower bound of 4.5, which will be less than or equal to the length L, which will be strictly less than 5.5. And we know the width will have 1.5 being less than or equal to width W, which will be strictly less than 2.5. Now, to find the lower bound of the area, which is just the length times the width, kind of like addition, we need to find the minimum values of each in order to multiply to the smallest area. So the minimum value of the length is 4.5, and we'll multiply that by 1.5, and that will give us an area of 6.75. So that's our area for the lower bound. The upper bound area will be the greatest two sides multiplied together. So the greatest the length can be is 5.5, the greatest the width can be is 2.5, multiply those together and you get 13.75. You can see how different those bounds are just from the upper and lower. Now that we've done that, we can finally write our limits of accuracy, which will simply be 6.75 is less than or equal to the area, and that will be strictly less than 13.75. Finally, we need to look at dividing limits of accuracy. So have a look at this question. John runs 10 metres rounded to the nearest metre in 5 seconds, which is rounded to the nearest second. What is the limit of accuracy for his speed? Now we need to know that speed is equal to distance, this 10 metres, over time, this 5 seconds. So let's start by writing the limits of accuracy for each. We'll start with the length first. We know that 9.5 will be less than or equal to the distance, which we'll call d, and that will be less than 10.5. And to find the limits of accuracy for the time, we know that 4.5 will be less than or equal to t for time, and that will be strictly less than 5.5. So here are our two bounds. Let's use some numbers to work out how we'll find the lower bound for the distance. So tell me, which one of these two fractions is smaller? 3 over 2 or 4 over 2? Well, obviously it's going to be 3 over 2. This is smaller because of this 3 here, which means that for the distance, which is also at the top of the fraction, we're going to use its lower bound because this is the smaller one. Now that we've worked out what that's going to be, let's work out whether we're going to use the upper or lower bound for time. So have a look at these two fractions, 2/3 and 2/4. Which one is smaller? Well, it's 2/4, which means that we need to use the larger number at the bottom. So we're going to use the upper bound. So therefore the lower bound will be 9.5 divided by 5.5, the lower distance divided by the upper time. And that will give us 1.73 meters per second. And that is our lower bound. The upper bound will therefore use the other two we haven't used. We're going to use the biggest distance and the smallest time. And if you have a look back at the fractions, you'll see this will give us the largest number. And so our upper bound will be 10.5 divided by 4.5, which is 2.33 meters per second. Now that we have our bounds, let's write the limits of accuracy. Now remember, in both the lower and upper bound, we use one of these strictly less than signs, which means it's all going to be strictly less than. So our final limits of accuracy will be 1.73 is strictly less than the speed, we'll call it s, and that is strictly less than 2.33. And that is our answer. So in summary, much like the one before, if A and B have these lower bounds and these upper bounds, then when you're multiplying them together to get the minimum value, you take their minimum bounds and do them together. And for the maximum, you take their upper bounds and do them together. And when you divide them, you need to be careful because you're going to take the minimum of A and divide it by the maximum of B in order to get the minimum. And to get the maximum, you need to take the maximum of A and divide it by the minimum of B. This finishes the entire limits of accuracy topic. Go have a look back at anything you don't understand, and leave some questions in the comments below if you need any help. That's it from me.